enterprises. The project supports collaboration between 7 Scottish universities and businesses based in Scotland. The project is funded by European Regional Development Fund and the CIC Programme of Scottish Government, which is currently managed by Scottish Funding Council. This is a live event, so if there is a fire alarm, we will have to stop. We will continue later, but if you cannot join us, then you can watch a video recording of this webinar in the next few days. We plan to finish presentations around 1:30, and then our speakers will answer questions asked by our online viewers. All our online viewers can start using chat facility to ask questions at any time during the presentation. So the title of today's webinar is Energy Efficiency Retrofit Cost-Benefit Calculator Phase 2. The Phase 1 of the same study was presented in our webinar on 8th of March. So if you have not watched that webinar, you can watch a video recording from our website, download from our website. This study was undertaken by Heriot University and Changeworks. And today we have speakers, Stuart Hay of Changeworks and Sophie Simpson of Heriot University. Our first speaker today is Stuart Hay of Changeworks. And Stuart, I would kindly ask you to start with your presentation.
Good afternoon, everybody. Thank you for joining us online. I'll take you through the development of our retrofit calculator, how we plan to use it. I'll give you an outline of what we're going to cover today. First of all, some basic background on Changeworks and who we are, and also about our partners Heriot. We'll cover the development of the tool, where we started from and where we got to. Then the recent refinements, we've tried to make it very relevant to a lot of things that are happening at the moment in terms of Green Deal and changes in building standards and that sort of thing. So we will cover that. Then we'll move on to the next steps for the project and where we want to take the project. And finally, I'd like to throw it open to everyone to have a discussion about what the tool can do for you. So about Changeworks. We're an environmental charity and a social enterprise. We're both. We work in a lot of areas, but principally in energy and waste, mainly in the sort of advice and research fields. The part I work for is Scotland-wide consultancy service. We have a range of technical expertise. We undertake feasibility studies, energy analysis, and do a lot of work around CO2 reductions, tackling fuel poverty, meeting Scottish housing quality standards. And we're interested in research and development projects where we can find new ways of tackling these issues with new products. We're particularly interested in the interface between buildings and people. And last year we won an award for some of our work. This is an example of a report we did, which goes into what you can do to retrofit older listed buildings, which are seen as very challenging. We went out to challenge that. We went into the World Heritage area of Edinburgh and did a project there, and you can read about that from our website. We followed that up with work on renewables, again in the same area, again challenging perception that you can't retrofit certain buildings because they're protected. And finally, we do quite a lot of technical work with Historic Scotland, and our most recent work has been around the Green Deal. And on this project, we worked with the Heriot School, the built environment, and it was a very useful collaboration. Heriot were perfect for this in terms of the multidisciplinary research but with particular focus and expertise on energy and buildings. Their work on low carbon futures and particularly tar base gave them a grounding in what we were looking for in our calculator. We're not that level of sophistication, but we needed to move beyond what was out there in the market. And we also were keen to draw on their other areas of expertise in terms of microgen, building energy demand profiling, fuel poverty, and building simulation. And it has been a very positive process in terms of taking our knowledge of a product and how we want to apply it and actually making it happen in terms of applying some technical expertise and programming to the tool. So what is Carbon Heart? This was covered in the last seminar, but I will do a quick recap. It stands for Home Energy Analysis Retrofit Tool. And what we were looking to do is calculate a number of things, including capital costs, energy savings, carbon savings, and per pound spent, which is the critical thing for most of the clients we work with. SAP and NHR ratings, so we know what level of improvements being achieved, whether the chosen retrofit strategy actually meets the level required by the Scottish Housing Quality Standard, and these standards are about to change, so we're kind of anticipating there will be more work needed in that area. An indication of fuel poverty, whether the effort made in terms of retrofitting will actually help reduce the level of fuel poverty. This is a critical issue in the area of rising fuel prices and of great interest to social landlords. And we've tried to anticipate how Green Deal and eco-finance is going to work, and so the proof is going to be in the pudding. We can read the consultation that came out today, and that's a really evolving area, but we wanted to be able to actually work out sort of best value in relation to Green Deal and eco. And we wanted to look at a range of scenarios in terms of what options gave the best value for money. What Carbon Heart does compared with other tools that are out there, it's quite a detailed tool. It gives a full analysis of all the different investment options and all those factors in one shot. So it's for all the stock, for all stock, but it tackles archetypes, but it also tackles sub-archetypes, which most other tools wouldn't do. So and there can be quite big variations within a building between a 3-bedroom and a 4-bedroom, whether it's on a gable end, whether it's on the top floor, that sort of thing, in terms of what strategies. So it packages all that up. It also analyses the impact of numerous variables, and these are not usually recognised by other pieces of energy software. One of the issues we were keen to develop this time was the issue of householder heating patterns. And this is pretty critical in relation to the Green Deal and the Golden Rule, because that will influence how much potential there is for people to make savings, whether they're using more heat or less heat than anticipated by other software. Taking some account of repayment and interest rates, that's quite significant in terms of the capital cost of these measures if they're funded through the Green Deal over a long period. Issues of inflation, we can look at that going forward. The Green Deal doesn't actually take that into account. It's based on today's prices. We felt it'd be useful to look at how things could go in the future, and the rebound effect is that all the savings might not be secured by the tenant. So we want to give a full picture in terms of what will the impacts be of a particular retrofit strategy. One of the things we were keen to use, and this was important to City of Edinburgh Council that we were working with, is to have an up-to-date database, particularly in relation to retrofit costs, and be quite specific, so that there were costs that the clients were comfortable with. And a lot of other tools are out there, but it can be quite generic, and we wanted to be quite specific on things like solid wall insulation. Again, on CO2 factors, these can vary over time. We wanted to take account of that. Fuel costs, another variable that we wanted to be updatable. And we wanted accurate real-life outputs. And and this is particularly important for solid wall. So we take actual property data into the model, but from the drawings, so we know what areas we're playing with. We know exactly the size of windows, those sort of things, and that ties in with the cost database. I've covered that. And it uses, at the moment, the model runs on using NHAR data. It could do RDSAP, SAP, and other tools as well. Probably it will evolve into using the software that's attached to the Green Deal, but as that's not out there yet in Scotland, we haven't done that. So NHR is probably quite similar. And it doesn't, as much as possible, it doesn't rely on generic averages, apart from those that are already been built into NHR, and we can also refine those a little, such as heating patterns, and take account of them, so we've got a bit more flexibility. So it's very well suited to complex property types. It's overkill for using it on a property that just needs a bit of loft insulation and some cavity wall work done. But for a complex hard-to-treat building with a solid wall insulation needed, this is the perfect tool for the job. So it's good for blocks, good for terraces and tenements. And those are two of those buildings we've actually used. The second one on the page, the 1960s building is actually the one we've done most of the testing on, and that has quite a number of different archetypes. And the picture at the bottom of the page is an example of a building we previously modelled, which is numerous different archetypes spread over all these different floors and elevations, and that can show you the number of archetypes and complexity you can get involved with. So it's a strategic investment tool for social landlords. It really is about showing what gives you the best bang for your buck. We start with a baseline performance. We then work through the impact of different retrofit scenarios. At the moment, we've probably run on 3 additional, so a low, medium and high cost scenarios, just for simplicity. And we try and work out which is the optimum, and then make recommendations of best value. Stage 1, as I've previously said, we wanted something that was quite accurate, that made the best of the data that was held by housing associations and social landlords, local authorities. We wanted to be able to offer good strategic advice. We recognise there's a need for many landlords that they're sitting on a lot of energy data. They are going to have to start investing to meet the next set of standards, and just tackle the rising bills that their tenants face. There's other obligations out there as well in terms of fuel poverty and CO2, which there's targets attached to them. We want to look at the most effective ways of tackling those issues. And we wanted to overcome, where we could, some of the limitations in relation to some of the existing tools that were available to us. So this project actually started about this time last year at a very basic level, but it really took off when we started working with Heriot. We got the Kickstart grant that made that possible, which this programme we wouldn't have been able to do what we've done without that additional funding. So that was very important to us. We started doing some trials on the software, so we know it works. City of Edinburgh Council data, we used that. We also used five council data, and we've also done some work with a small housing association in the northeast of Scotland. So we'll hopefully have details of some of those case studies on our website in the not too distant future. We recognised we could refine it further. We wanted to do more work on the CO2 calculations, particularly into user behaviour of the properties. The graphic outputs could have, we recognise, be better in terms of the information provided to clients, and particularly important was giving us some flexibility in terms of modelling Green Deal variables. I'll now hand over to Sophie Simpson, who will set out in detail how the tool actually works and how it was developed.
So I'm going to start first by just providing an overview of what the first stage of the tool development established. Essentially, the tool consists of 5 main stages in order to input the information and report the outputs. So the first stage, then, that's where you input quite a lot of detailed information describing the different property characteristics and details. At the moment, that's set up basically in a format which is similar to the survey data for NHER. The reason for that was that we wanted to have a system that was familiar to the user, and also the purpose is that they can input all the information in relation to the property. All that data is not necessarily used throughout the calculations, but it provides a system where they can record the information so that when they look back at the document at a later date, they can quickly familiarise themselves with all the data associated with the project. So the next stage was to consider the scenario measures. So as Stuart was summarising there, then you can have up to 3 different scenarios, and you can categorise these based on the costing system. So you have increasing costs for each one. And then the next stage was to reference one of the databases in order to try to determine the associated costs with installing these measures. The databases are referenced throughout the tool in order to complete the calculations quite often. So they form quite a key component of the tool. One of the key benefits of these databases, there's a number of them, and the key benefits is that it allows the user to have a quick overview of all the information, all the assumptions that they're using for the calculations. It also provides ease of maintaining this information, so the user can update this regularly as new information becomes available or values change, so it's ongoing, and the effect of these will be automatically updated within the calculations as a result of this. Once all this information has been entered, then the user just needs to enter in information on the energy performance data, so the annual energy consumption and the CO2 emissions, and that allows them to process and interrogate the information, so they can look at operational cost, energy consumption, CO2 emissions, bill savings, carbon emission savings, and also kind of investigate what the impact this will be on the Green Deal financing mechanism. So in terms of what this means for the project level consists of a number of different archetypes. So as Stuart was describing, an archetype can represent, for example, a row of terraced houses or a tenement block of flats. So you have a number of archetypes representing these different types. And the tool is capable of modelling up to 10 of these. This example here just shows 6. And within each of these archetypes, then you can have a number of different sub-archetypes representing the different dwelling types which exist within these. And you can have multiple representations of these. So if you've got 2 of a similar sub-archetype, then you can include that data. And what this means is that for each archetype, you can then model up to 10 sub-archetypes. So that creates opportunity to investigate up to 100 different variants, essentially. But when you're actually considering the number of sub-archetypes which exist, then that potentially allows you to consider even more dwellings within this. And so what the sub-archetypes relate to then, it's where you have to undertake an individual energy performance calculation. So for example, for this first archetype, you've got 3 different sub-archetypes, which might represent a ground level apartment, or you've got a different calculation associated with a mid-floor apartment or top floor, depending on the heat losses. Or it might represent the different size of apartment, for example, 3-bedroom, 2-bedroom, or we're talking about terraced houses, gable end terrace house or mid-terrace. The next stage, once the users input quite detailed information, so that's in relation to the heating systems, the windows, the property dimension data, then the user goes on to specify 3 improvement scenarios. And so the examples we start here, we've got the first scenario 1, which is the wall insulation, loft insulation, floor insulation, replacement boiler. The next one goes on to consider all of these with the addition of solar heating, and the third one considering same as scenario 2 with the addition of A-rated double glazing and balcony glazing. An important feature that the tool needed to accommodate is that we needed to have the facility to override where any of these measures weren't appropriate for a specific sub-archetype. So for example, the loft insulation isn't going to be relevant for the ground floor flats or the mid-floor flats. So the override facility allows the user to eliminate this from being included in the calculation of the costs. So the cost measures, that then again references the database of costs. And what we can see from that is that there's quite a considerable range in data. So for the example study that was undertaken, looking at the 6 different archetypes, for the first scenario, then you're seeing a range in costs associated with the sub-archetypes depending on what measures they could accommodate, from about 6,000 to 11,000. Whereas for the second scenario, you're looking at a range of about 9,000 up to 14, and 11,000 up to about 16 for the third scenario, so quite a significant range. Then the next stage is that the user can then input the information on the energy consumption and CO2 emissions, and this allows them to process this data so that they can assess it in a bit more detail. And they'll be looking at the annual energy consumption figures, the annual CO2 emissions, operation cost, cost of the work, and then graphs can be used to report this data quite quickly and effectively. So the examples here, we've got the first one which is showing the CO2 emissions associated with the total project, and this has a baseline emissions and then gives you the breakdown for the scenario 1, 2 and 3 in relation to each archetype's contribution. There's alternative ways that you can represent this data, so as we were discussing before, you can look at the CO2 per pound spent, and so there's a range of graphs that the user can use to most effectively communicate the information they're getting from the tool. So in terms of the stage 2 development, there were a number of key areas that we were quite keen to further progress. So the first section we wanted to look at was providing a much more detailed calculation of the CO2 emissions. So in terms of this, then previously we were looking at the carbon intensity is defined by the calculation methodology, whereas we wanted to consider a much broader range of fuel types and the carbon intensity associated with them dependent on, for example, their generation methods. And we also, once we had this at a much more detailed level of calculation, we wanted to provide a much better graphical output of this information. The next section was looking at the costs. So previously there was being a single cost entered into the database representing the cost of installation of a certain measure, so for example the wall insulation or the loft insulation, but it was recognised that there's quite a considerable number of other costs in relation to that in terms of actually installing the measure. So we want to kind of take into account like the installation cost, the project management cost, a number of other factors, like for example if the householder needs to be decanted, they need to have their contents stored while the work is being carried out. So that was the next section. In addition to this, it's not quite known yet how these extra costs will be accommodated by the Green Deal. So the next section was to kind of consider what was the impact if these were included, but also provide the opportunity to kind of further interrogate the consequences, for example, of the loan interest rate and the repayment period, and how this affected the feasibility of the Green Deal being used as a loan mechanism. So just to summarise, then the areas that we'll be looking at that we're working on are predominantly the more detailed CO2 calculations, the enhanced graphical output of the CO2 data for the clients, the incorporation of extra costs of work, and the more detailed analysis of the Green Deal variability factors. So starting with the CO2 emissions, previously then when the user was specifying the property details, then they had the opportunity to input the fuel type used for each of the end uses. So the next stage to calculate the effect of the CO2 emissions and potential savings was for the user to undertake the energy performance calculation, so for example in this case NHER, and from this they would output energy data and CO2 emissions. Then using this, the fuel type data would reference one of the databases, and this would be combined with the energy information to determine the fuel costs. So in order to try and make this a much more efficient process, then again we're still using the referencing of the fuel type from the first stage, and you enter the energy data as before, but what we've managed to do is reduce the amount of data input by using this database and further expanding it so that you're also including carbon intensity data within this database in relation to the various fuel types. So this means that you're automatically calculating the CO2 emissions and the fuel costs simultaneously. So in terms of how this works with the actual spreadsheet, then what you can see here is just a screenshot of the spreadsheet, and you're seeing it for one sub-archetype here, 1A, and it goes on to consider all the different archetypes within the project. And so the first thing that the user does is enter the energy data, and it's colour-coded in yellow there just to quickly identify where the user actually needs to input information. And the fuel type, which is colour-coded in purple, and that's just to show them that it's automatically referenced from elsewhere within the spreadsheet, so that's automatically input in for them on this spreadsheet. The next stage from that then is once it references the databases, the information in relation to the fuel costs and CO2 emissions are automatically updated within the spreadsheet, and then this goes on to consider the costs per year and the potential savings. So this provides a much more efficient method of inputting the data. So they've only got to input the energy as opposed to the energy plus the CO2 emissions. So the benefit of this is that it also reduces the risk of error, human error, for example, inputting the information, because your energy is always going to be linked to the CO2 emissions as opposed to realising any discrepancies between energy and CO2 emissions. And it also provides the opportunity to provide a much more detailed calculation. So you can have a much broader range of fuel types and show greater variation of the carbon intensities associated with those. You can also take into account different carbon intensities in relation to the method of generation. And the fact that this information is kept separate within a database means that, again, you've got the benefit of it being able to be maintained and updated as these values change over the years and more information becomes available. So this graph here is just an example of one of the outputs, and this is showing the information in relation to one of the archetypes, archetype 1. And you can see that where the data was entered for kilowatt hour, the energy information, it's entered based on end uses. So you have your space heating, your secondary heating, cooking, lights and appliances. So this shows you the annual CO2 emissions associated with this single archetype. So it's taken into account all the sub-archetypes and the number of archetypes that exist. So if there's 2 archetypes, 3 sub-archetypes, 2 sub-archetypes. And this allows you to just kind of quickly identify which scenarios have been particularly successful, where they have been successful. So for example, if they've been most effective at reducing the space heating, and hopefully kind of identify areas which may become more of a concern in the future or require future treatment. So this information is reported for the baseline and for each of the improvement scenarios. An additional feature is that you can also input percentage reduction targets. Caution needs to be demonstrated here. For example, here we're showing the 2020 reduction target. It's based on a percentage reduction of the baseline, so this doesn't actually represent it compared to the 1990 baseline period. So you just need to be clear when you demonstrate that. And so this information is reported at a number of levels. So first of all, you have the main project level, so all the emissions associated with the whole project, so that's representing the information for the baseline at 3 improvement scenarios for all the archetypes that exist within the project. And then, as the previous example demonstrated, you have the archetypes. So again, this is showing all the sub-archetypes that exist within that and the number of these as well, taking that into account. And then there's also a feature which, rather than representing the information for every single sub-archetype which exists in the project, then the user can use a drop-down menu to select which sub-archetype they want to produce a graph for. So if you've identified one which is particularly problematic or particularly successful, you select it from the drop-down menu and it will automatically update the graph to report the information for that sub-archetype. This is shown at individual dwellings. So for example, if the sub-archetype, if there's 5 properties of that sub-archetype, it will only show the information for 1 property. This moves on to the next feature that we wanted to accommodate within the tool, and that was incorporating the extra costs. So previously the tool had just kind of reported on capital costs, or essentially used a single figure to represent the cost of installing a certain measure. So for example, you had one figure representing the cost of installing loft, where that was on a metre squared basis, loft insulation. But it was recognised that you wanted to have the ability to kind of take into consideration all the associated costs with that. So it was identified that there were about 4 categories that we could separate this out into, and these were installation costs, additional costs, professional costs, and maintenance costs. So in terms of the first two, installation and additional costs, then this is based on information that is stored within another database. So the user can then update this and again maintain records on this as they get more information available. To the screenshot here, just get this. You can see that it's just providing a list. This is referenced in the database here. So for example, you have your 13-week decant 1-bedroom flat. So it's in relation to the time of work and also the size of the property. So what the user does is then select that in order to work out what the associated costs, and this will update in the screenshot that you see to the right of the page there. So for the top example there, one where you've got 13 weeks to apartment, removal from tenancy, return and storage packing of materials, then that's noted that it's about £732. So the user updates this for each sub-archetype, for each scenario, and then a summary is included just at the top here, which takes into account where there's multiple installation costs. Sorry, the green arrow is not moving. So it takes into account the multiple, if there's multiple installation costs, it will summate it up here and provide an overall summary. Because this is also, the extra costs are also related to what measures are applied for that specific sub-archetype, then it was considered important to also provide a summary of what measures were being applied. So just at the bottom of this screenshot, then this looks at what measures were selected for the scenario, so in this case it's scenario 1, and it also automatically recognises which measures have been overridden and will exclude them from this list. So when you're inputting the data in the upper section, you can refer to this list just to remind you of what extra costs are necessary. So it's not quite yet known how these extra costs will be included within the Green Deal or whether they need to be excluded and charged as additional. So we wanted to make sure that the tool was capable of providing facility to let the user opt in or opt out of including these extra costs. This led to the development of the Green Deal loan sheet within the tool, and the first section provides an overview of the information in relation to each individual sub-archetype. So in the screenshot to the right there, the first section provides a summary of the operation cost, potential savings per year and the cost of work. So this is just to provide reference based on information that was previously calculated within the tool. So the next section, it then refers to the page I was just describing previously, which is in relation to the extra costs. So again, it's just summarising within this section outlined here the installation, additional and professional costs. The professional costs, I forgot to mention, is that they're applied as a percentage rate of the total cost. So it looks at all the costs associated with that particular dwelling and applies that as a percentage. What this section of the page does is it allows the user to choose whether they want to use the include these costs within the calculation of the Green Deal. So they can select yes or just leave it blank if they don't want to include it. If they select yes, what happens is that when they calculated the adjusted cost of work, it will automatically include that within this. Whereas if it's not included, so for example the professional costs are excluded here, it will calculate what these are and leave this as remaining costs. So what you have is an overall summary of the adjusted cost if you have changed them. If not, then it'll just be the original cost calculated and the remaining cost, as well as the maintenance costs, which were also specified on the previous sheet. So the next section is to kind of try assess some of the characteristics associated with the loan. So what this allows is, again, it was highlighted in yellow, so that's just to indicate that the user has to input information in relation to this. And so the user specifies an interest rate and a repayment period associated with the Green Deal. And what the spreadsheet will do is automatically calculate the repayment value associated with. This is based on the adjusted cost of work and the interest rate and repayment period. It's hoped that this will essentially be lower than the potential savings, which were summarised just at the top of the sheet here. But that's not always going to be the case. So the next stage is also consider, do we need to look at the energy company obligation, or the ECO? So just move into the next section. That final part, and this section of the sheet which has been outlined here is just in relation to scenario 1, so this same process will be applied to scenario 2 and scenario 3. The next section in relation to the energy company obligation, the point of this is to kind of try immediately clearly identify which sub-archetypes pose a risk in that they are going to need to require an energy company obligation. So that's where you have the section which highlights, yes, this one needs more attention. One factor that we wanted to kind of include within this is that it's hoped that the householder will essentially realise some kind of savings through undertaking the measures and taking out the Green Deal loan. So what we wanted to include here is a target bill reduction. So this looks at where you have the savings which are realised by the application of the improvement measures. And we wanted the householder to be able to kind of realise maybe about 10% of that, for them to kind of benefit from about 10% of that value. So that means that in terms of the repayment value, it then has to kind of be even less than the cost of savings so that they can benefit from that. If it doesn't, so for example, if the repayments are much greater than the potential savings taken into account this target bill reduction, then that's where you get this message saying, yes, you need the energy company obligation. And it just tries to identify, is this because the repayments are greater than savings, or is it because it exceeds a limit? So for example, at the moment this is set up for a £10,000 limit on the finance available to support the Green Deal loan. If you don't want to include the target bill reduction, it's just a case of leaving that as 0. But then what happens is this final calculation here, what it's essentially doing is just saying, right, if you have these potential savings, this is how much you're going to be able to contribute towards loan repayments. So on that basis, this is the amount of additional funding that you're going to need to finance the work that you want to undertake. So it just clearly identifies that. So this section is undertaken for each sub-archetype which features within the spreadsheet, and it's undertaken for each scenario. But essentially the information that the user's inputting is in relation to the interest rate, repayment loans, and the target reduction rate, the target bill reduction. So the next section, it was just to kind of try further analyse the factors which impact on the Green Deal loan, like impact on the feasibility of taking it out to finance your improvement measures. So instead of reporting information on all the sub-archetypes, what this is trying to do is allow the user to select any of the ones which they consider they want to investigate further, and then using a drop-down menu, they'll select one sub-archetype to interrogate. And then what the page will do is that it allow the results for each of the 3 scenarios to be reported on one page, so you compare them directly and see what the effects are. And so first of all, it provides a summary of the information associated with this particular sub-archetype. So you're looking at the operation cost, bill savings, just summarising information which has been calculated previously, the loan repayment, the energy company obligation, the contribution, and it's also looking at the cumulative profit loss. So you're seeing if you're making this amount of savings, your loan repayment is this, are you making a profit or a loss each year? And if so, what's the effect of this over a number of years? So having this is demonstrated over a 25-year period. So what this allows you to do is that although you may be making a loss over the period of the loan, after that then it's possible to recoup that where you're actually making greater savings and not having to pay the loan repayment. So for example, if the loan repayment's over 20 years, then you have 5 years where you're just realising savings. And this can kind of balance out. So it looks quite scary figures on that just now, but it's not always that bad. So in terms of how we wanted the user to interrogate this information, there are kind of 3 key sections that they can use to investigate this further. So the first one is a rebound effect. So if the user wants to select, right, I want to consider if we apply the rebound effect, how does that affect the potential savings that can be realised? In addition to that, then loan details, like if we change, then how does that affect the loan repayments? How does that affect the overall balance? Or for example, if we have an increase in fuel prices, then can that be contributed? So the spreadsheet's set up so that all of these factors, so the figures associated with all of these factors can be investigate each of the individual sub-archetypes in a bit more detail and understand the extent to which these are significant. So if we take the centre example here, so in terms of the loan details, then this just shows 2 screenshots. And so we have the first screenshot, just go back to that one. Then essentially it's just giving you a summary of the key information, and then here it's just reporting the interest rate and the repayment period that were determined for that were input previously on the previous green deal sheets, which provide an overview of all the sub-archetypes. So for this single sub-archetype, you're seeing that you've got annual repayments of about £600. So in terms of allowing the user to investigate that a bit further, then the arrow buttons here can just be used to kind of play about with these figures. So the user can use these to kind of increase the interest rate, decrease it, and the same for the repayment period. And as soon as they do that, then it highlights in orange just to kind of clearly identify, just improve the usability of this, clearly identify that the values have been changed from the original values. And they can play about with these figures. And as you can see here, then the repayment cost has varied because of these quite significant changes. And then as a result of that, you can see, does this help with in terms of the energy company obligation? Has it reduced it? In this example it's not, but you can see that it's reduced it by about £1,000, over £1,000. So it's just to let you get a measure of what the impact of this is, and if you're able to provide financing from another mechanism. Just to kind of summarise then, the key aims of this tool were just to kind of provide a system that would be quite, once the user was able to familiarise themselves, then provide a process that would allow them to kind of interrogate and analyse quite a lot of information, and hopefully provide the opportunity to kind of identify appropriate strategies for improving a certain type of building stock, determine how effective these strategies are, and hopefully improve the operational performance and identify which strategy is going to have the greatest benefit or be most cost effective or successful. I'll pass it back over to Stuart.
So just to summarise, we intend this to be a commercial tool, although we're a not-for-profit social enterprise, and it has a social purpose in terms of what it's trying to achieve. It does have to sort of pay for itself. We want to make it available to all social landlords and anybody else that's interested in developing refurbishment strategies, so that they can achieve the optimum carbon saving for the least amount of money and target issues like fuel poverty effectively. We want to be able to demonstrate the value of having a high level of detail and accuracy in these calculations, and that's the power of the databases that support it. There's a lot of flexibility there. I'll reiterate again, it's all about maximising value for money. This is the sort of era we live in. We've got very challenging targets to meet, and it's about concentrating on the properties that will deliver the most amount of carbon savings with the least amount of money, and not investing in measures that for the extra value, the extra cost, are not delivering significantly increased carbon savings. And we also want to address a whole load of priorities at the same time, utilising data, which includes the Scottish Housing Quality Standard, either in its current form, which a lot of certainly social landlords are making good progress on, but will have more challenges in relation to the next series of standards, and there is still challenges in relation to hard to treat properties, which this tool would help with. fine-tuning fuel poverty strategies in terms of where you place investment, where that will most benefit tenants, CO2 reduction in terms of climate change targets, and also being able to utilise the Green Deal and eco effectively by understanding what sort of carbon savings you're getting for the amount of money, being able to negotiate the right amount of eco. It's still unclear how all those mechanisms are going to work, but this tool will give you as much information as you'll need to negotiate things and develop up your strategy in terms of Green Deal. We're looking at a number of next steps, opportunities, and a few challenges as well. Green Deal, it's an opportunity, it's probably a challenge as well until it settles down and we all know what's happening. Energy company obligation is the same, but there's a big opportunity there, and that funds a lot of measures that previous schemes have not, such as solid wall installation, and that's what we've tailored the tool for that. The housing standards, as previously mentioned, that they will be difficult to meet with basic measures, so you are going to have to measure, you're going to have to model more complicated retrofit packages with a range of measures. There is going to be a need to try and, as best as possible, fuel-proof, poverty-proof buildings because of rising fuel prices. People's incomes aren't going up, but their bills are. That's a big problem for landlords because it's putting pressure on their tenants. But there's also a big social need to do something about that, and we want to help in that area. CO2 targets, there were some earlier graphs, these will be challenging to meet, and they'll be challenging to meet cost effectively, and we hope to provide information in relation to that as well. And I can't reiterate this enough, it's all about big investment and making the most of a limited pot of funding. So there's a small upfront investment in terms of utilising this tool, but then you could be spending millions on a portfolio of properties where you're spending £10,000 a property to do solid wall upgrades and other things. So this tool works out the actual feasibility of that and the optimum strategy. Further information, we're always interested to know where we can work with people, where we can do joint projects, get this tool out where it will be most useful. The principal person leading the project is Nicholas Heath, who isn't here today, so you can contact him or you can contact myself. Be very pleased to work with any social landlord or other consultancies, Green Deal providers. I think the tool has a lot of applications. We're keen to explore them, and I'm keen to now answer some of the questions that have been lodged. Thank you very much for listening.
Thank you very much, both to you, Stuart, and to you, Sophie. And we can now start with some questions that have been asked by our online viewers. The first one is from Olubukola Tokede of Edinburgh Napier University, asking what program was used to develop Carbon Heart?
I'd like to say that it was some fancy, very sophisticated database. It's actually an Excel base at this stage, and we did that for a number of reasons. It's quite nice for at the development stage, and it gave us a lot of flexibility, and it's also something that clients are familiar with. What if the product was to take off? Then I think the next logical stage would actually to put it into a proper database. But at this stage, we're still developing the tool. We're still exploring sort of the level of demand and potential for it. That we're not quite there yet, but that would be an aspiration.
Thank you. Comment from Jennifer Sanfield of Page Park Architects. Future analysis of extra costs could include whole life costs, maintenance, product replacement, recycling, etc. You have mentioned already maintenance, but whether recycling potential or product replacement could be included in calculations, do you think?
I guess, well, at the moment then, in terms of like future costs, kind of trying to look at like in terms of like bills, for example, how those will change. I'm not sure, like it potentially could be developed further. That could be another aspect that in the future.
Sophie will be able to confirm this, maintenance costs, that can be anything, for instance, the boilers or the routine maintenance cycle on that, that needs to be taken into account making these investments. So that it's got some flexibility there, and we could add in further issues. We sort of drew a limit on that. It depends how important these things are to a client. We were looking at capturing a whole, as far as possible, a whole life cost, and there's all the things that people forget about, such as if you do more some of the more extreme retrofit scenarios where you're doing internal wall insulation and a heating system upgrade at the same time. The chances are that the tenant is not wanting to be in that property, and that could take a number of weeks, and you're going to lose rent and that side of things. And the landlords need to build that into their strategy. If you're doing a lot of properties, that's a big investment cost. So we were keen to, when we provide a cost at the end of this, it's the actual real life cost. It's not just the cost of a basic install or the basic measure. The installers will always, try to minimise how much things are costing. It's in their interest to do so. They won't look to all the extra costs that just will sort of turn up on a job. But we feel that that's important in terms of developing these big programmes going forward.
There is a question from Jack Wong of National Energy Foundation. How does the tool deal with different lifespan of energy improvement measures within one Green Deal package, say, including boiler, where a lifespan is expected less than 5 years in GD, and a loft insulation, which is around 25 years? So how does the tool deal with different lifespan of energy improvement measures?
Well, what it could potentially do, it's not set up at the moment for this, because obviously when you're getting a Green Deal loan, then you're trying to get one Green Deal loan value, but that's obviously a factor which needs to be taken into account. So what you potentially could do is incorporate those as, model them as additional costs. So where you have your maintenance costs associated with the boiler, you could then incorporate additional costs. Then you've also got the issue of trying to include inflation and other factors.
Yes. While we are waiting for questions from our online speakers, I can also say that today we have with us one of our members, who is Paul Wilson of Coral Concepts, who wanted to come specifically to this webinar and maybe to ask some questions. Paul, you're welcome if you have some comments or questions to ask now.
Thank you. Yes, we are developing a range of user-friendly heating controls with the emphasis on user-friendly. Your model, as you say, incorporates the system type for the heating and fuel type. Are you able to also include the heating controls that are available to the user, and indeed how these might be used by them?
Yeah, I've not gone into much detail within this presentation, but as part of this, there was like an additional sheet produced which would allow, as long as the alternative calculation was undertaken, which took into account the changed heating pattern, then that would obviously impact on your the energy consumption associated with the heating. But what the additional sheet provided the opportunity to do was to undertake this alternative calculation based on the heating profile that you had specified and input that, and then that allows you to compare that information to the original information if you want to, or just kind of investigate what the impact of that is on the savings realised and how that impacts on the loan as well, and the carbon emissions.
Thank you very much. Now we have a question from Fiona McLennan, who says, have you formed an opinion on whether Green Deal financing is more beneficial than normal high street lending? It seems unaffordable and may contribute to fuel poverty. Any comments there?
Yeah, yeah. This is slightly beyond what we've modelled, but so far, but. What we do know is it comes down to what the interest rate is at the end of the day. If the Green Deal can come in at a very low interest rate, then then it will work. If it comes in at some of the interest rates that we've modelled things on in relation to some of the best deals in the high street, then it doesn't. It does cause problems in terms of the burden of that interest. It does eat into the savings, and it definitely isn't suitable for people on low incomes when you're trying to reduce fuel poverty. We modelled 10% saving, trying to achieve a 10% saving, which is kind of the minimum you're likely to persuade people to get interested in terms of a bill saving. So, and that is very, it's quite expensive. It's quite difficult to achieve that with a high interest rate. So the eco is quite important, and for lower income households, really you want to give these measures free so that they get the full benefit of them, and that some of the value isn't taken away by the lenders.
Also, there is a question from Gloria Lowe. Could you clarify who you intend the users to be? So far.
At the moment, the users are Changeworks in terms of we will input the data into the model, and we'll do the modelling for the client. In the future, we might change that. We might make it more available. It's still quite a young product, so there might be other ways of kind of taking it to clients and taking it to market. So. But we're happy to discuss that with people, discuss sort of partnerships of getting out there. We're a small organisation, and we're always keen to collaborate and work with like-minded organisations.
I have one question. Do you think that user behaviour is very important also for any future savings, and how can you at all, if at all, incorporate that into any tool such as this one?
It's obviously quite a critical element. I think it's definitely something which needs to be taken in consideration, and so the purpose of the additional sheet is to try kind of accommodate that to a certain extent, but also at the same time the sheet needs to be able to calculate it based on how the financing mechanism is going to be calculated and the feasibility of that. In terms of communicating it to the user, then taking into account behaviour will be quite important, but it's also important to think beyond the spreadsheet in order to communicate to the actual householder how they are going to use their energy efficiency system, to make sure that they understand the systems and how to use them most effectively.
With the user, we at the moment we've got the model set up that it's looking at kind of standard scenarios in terms of people with extended heating patterns, or people that are in their house less and they're not using their heating patterns, and they wouldn't see the full carbon saving. So we've got a range of standard behaviours that probably gives a good indication, and that's where it goes beyond the existing models, which is kind of an ideal scenario in terms of somebody's heating pattern and lifestyle. Within the model, we can look at some variables in relation to that, and for a social landlord, they can decide if some of their tenants fit into those categories. That'll give them a good indication of whether this investment is going to be worthwhile, because it might not be if everybody's out all day and they do have a very short heating cycle. On the other hand, if you have a tenant who is in their house for a long time, it's quite important to make sure that they're sort of warm and comfortable and that it's affordable. So that might well justify increased investment to lower their fuel bills.
Do you think that including smart metering would help raise awareness of occupants of their energy use and influence their behavior at the end? Because if that would be the way to know how much energy they are really using.
I think it could definitely potentially have a significant benefit, but it's also dependent on the occupant's interest in that. So how are they able to interpret that data? Are they able to understand the consequences of that? How effectively is it communicated to them? So it could potentially, but on the other hand, then it might be more beneficial in understanding how alternatively to model their behaviour and incorporate that within the tool. I think it essentially depends on how interested they are in that kind of information that's reported to them.
It is difficult to establish a baseline in terms of user behaviour. I mean, there's so many variables there. And then taking account of what level of impact energy advice can have. I mean, I think what we would like to do is put something in the model in relation to energy advice as an investment and what that could deliver. There's a number of challenges in doing that, in that unlike the other physical measures to the property, you don't know how long the user is going to respond to that advice, and then you have to know that the next set of tenants are going to get the same advice again. So, because there is turnover in these properties, of any property. So that's another area of complexity, but would be useful to model that, because I think there is a trick being missed in terms of behaviour change and how effective that could be in terms of investment compared with insulation. That's not to say insulation isn't important, it's just to say that you can do things quite quickly and at potentially lower cost if you provide advice and it's sort of seen as a softer thing, and maybe it shouldn't be.
We have a question from Michael Hodgkinson saying, would it be possible to take the calculator back to the homeowner, say after 6 months, to educate them into better energy use?
I'm not sure if it's necessarily at an appropriate level for a householder to kind of absorb that information. So it might be possible to it might be more beneficial to understand what their behaviour is rather than report to them what they're not meeting or what was assumed. But I guess it could potentially kind of say, like, these were the assumptions that were made, how are you behaving in relation to that, and then understand why their behaviour or energy use is different rather than kind of reporting to them.
Do you believe that maybe accessibility of online data of average energy use in different areas of United Kingdom would be useful for homeowners to be able to compare what energy they are consuming compared to maybe their neighbours?
I mean, I think there is some evidence as a behaviour change tool that is quite good to actually give people an indication of are they using more energy than they should do. And I think a number of energy companies in the United States have actually done this.
I think you need to have a bit of care of the information that you're communicating, because obviously you need to have a similar type of property to compare to. So for example, if your neighbour's got a house half the size or double the size, you don't have that same kind of comparison, but understanding how your behaviour varies compared to maybe similar types of properties or similar family compositions might be more beneficial.
Okay, we do not have, do you have one more question? Yes, please do ask, Paul. Yes.
Right. This is all in the context of retrofit, I take it, but presumably you can use this model for ascertaining what the best routes are with new build to achieve the biggest saving given amount of money.
It's not something we thought there was probably other tools out there, design tools, that would do this. That's not to say that if you had a design, you could input it into the model and you could add on things to it. For instance, you could see the benefit of putting on a solar panel that wasn't previously in the original design, and also take account of the cost of doing that. On a per property basis. So it is quite a flexible tool in that regard, but it wasn't designed for that purpose.
You have mentioned that the tool was trialed with 2 organizations. What were the experiences and lessons learned from those trials?
It did what we expected to do, which is good, and we also found the value really, we recognise that the full value is the more complicated the archetype, the more you get out of this particular piece of software. So for sort of very basic improvements where there's only very similar properties and a few basic measures, we sort of recognised that possibly that's not, you don't need to do that sort of thing. Although you could still look at issues such as the user behaviour and the scenarios in the Green Deal and all that sort that side of things. So it was useful for that part of things, and we just became sort of slicker at inputting the data and working with other people's data and recognising the limitations of what data is out there in terms of what housing associations hold in terms of the drawings and things. We've designed the tool to be quite specific, and obviously we need access to drawings and things like that, and it takes a while for these things to be dug out, and in some cases they don't exist. So that was a few things that we didn't quite realise along the way, but at the end of the day it did what we hoped it would do. We're still to make sort of final presentations to the organisations we've worked with, and one of the case studies needs a little more work, but those are the sort of main findings.
Mm-hmm. Do you plan to collaborate with any energy companies or investors who would be interested in engaging into Green Deal to see how they see the tool and whether they can contribute in any way in its further development or in its use?
I think that's something we have in mind too, that with the Green Deal, some of the people, it's all about selling carbon savings, and if this can help identify how your pound per carbon saving, it could be a tool that could be applied in that area. So we're sort of keen to explore that with organisations. We don't know who all these organisations will be yet, or how the energy companies are going to deliver their Green Deal and eco obligation, with their eco obligations. Obviously, the Green Deal, that's slightly separate. So when these organisations, we definitely like to speak to them, because I think this tool could be useful to them.
Here is a question from Gloria Lowe. If the calculator is not easily operable for everyone to use, including homeowners, then you are limiting the use of this tool to certain trained researchers and designers, and only allow changes during design phases, or to publish results only. How is it supposed to affect change?
We didn't design that for homeowners. That wasn't the objective of the research. There is tools out there, online calculators and things that can give people some indication of their carbon emissions. We were looking for something that was for people that were going to invest large sums of money on retrofit programs, and had challenges such as housing quality standards, climate change targets, etc. So it's designed with that in mind. For the individual homeowner, I mean, it should be they will get a Green Deal assessment. That market should be addressed through that sense. So we aren't competing with that market. And I'm sure there will be a range of online Green Deal calculating tools. What we can do with our calculator, of course, is we can do some verification work and that side of things, depending if there was funding available, looking at things like the user behaviour and how interest rates, how that might all affect what the assumptions behind some of the advice that's out there.
Kind of provides a tool that's kind of capable of modelling quite complex buildings then, essentially, so you're getting quite a lot of different sub-archetypes within one group, so it allows a lot of information to be summarised for one kind of quite complicated building type.
Have you already presented this to social landlords, or do you plan to speak to them and ask their feedback on the tool?
We've spoken to some social landlords. We're just waiting for our case studies to sort of be finalised, and then I think the next stage will be to go out and discuss if they're interested in using the tool and how we can work with them and see what their objectives are, how we can help them meet their objectives. I think is the main thing, because it's quite a changing area with the Green Deal, eco, new buildings, new minimum standards, and depending on the organisation they're part of, it might be fuel poverty, it might be climate change. So it's all about working out what people want, and then using the tool to actually meet those objectives.
Okay. We do not have any questions from our online viewers. Any questions here from our audience? No? Just to finalize the whole presentation, do you do you want to say anything more about future research, future plans in this area? Or is this now a package that is completed? Any new suggestions for further development? No?
I mean, I think the key for us is to get this out there, to work with more social landlords. What that'll help us do is build the databases behind it, get a handle on costs, because I think that's where this brings costs and carbon savings together, and also allows you to see the costs of meeting other objectives. So that's what we would like to do. If we can use it as a research tool, we're keen to work with Heriot again and other academic institutions in Scotland. And you know, I think I would sort of conclude by sort of recommending sort of Kickstart programme. It's been really good for us in terms of we would never have had the time to develop the expertise to create the model as it is now. You don't have those opportunities in a commercial organisation or even a semi-commercial organisation as we are when we're a social enterprise, but we just don't have the scope to go into the depth that Heriot were able to in terms of developing this tool and developing a logic to the model. So yeah, if other people are out there that look for avenues for academic collaboration, and well, hopefully this one will pay off this year when we go out there and start working with potential clients.
Thank you very much for your comments about the project and its assistance for collaboration between universities and small to medium-sized enterprises. Thank you very much for your presentations and all the answers. So now it is really time to close our seminar and to attract attention of our online viewers to our next webinar, which will be tomorrow. The title of that webinar is Reduction and Eradication of Fuel Poverty via Renewable Energy Technologies. And the speakers will be Professor Tariq Munir of Edinburgh Napier University, Graham McLennan of Solas Scotland Ltd, and Leanne Evans of Solas Scotland Ltd. So we look forward to welcoming you tomorrow, and thank you for watching this webinar today. Thank you.